So we're well on our way to filling out the unit circle, to knowing all of the exact values in degrees of the entire unit circle. Again, because the x-coordinate has to be bigger than the y-coordinate in this right triangle with the angle at the point of origin being 30 degrees, I know that the cosine of 30 degrees has to be larger than the sine of 30 degrees because of the makeup of that right triangle. So the cosine must be root 3 over 2, and the sine by default has to be 1/2. Since the x-coordinate is the smaller of those two values at 60 degrees, that helps me figure out which is cosine and which is sine of 60 degrees. Much better, much more accurate, much more trustworthy than memorizing elements in a table. So again, all we have to do is follow around what we know to be true of either reflecting points in the plane or reference angles. Whatever helps you finish filling out these exact values around the unit circle, that's what I want you to use. If it's reflections of the point over an axis, that's fine too, because in essence, we're using that. Here, the x-coordinate must be negative, and it must be the bigger of those two values. The y-coordinate must be negative in quadrant 3, and it's going to be the smaller of those two values. That relationship is reversed for that angle measure. For 300 degrees, we have the smaller of the two x values, and the bigger of the two magnitudes or values must be the y-coordinate. Since we're in quadrant 4, the y-coordinate must be negative. Here we have a positive root 3 over 2 and a negative 1/2. You need to be able to start with a blank page, draw the unit circle in the xy coordinate plane, and label all angle measures accurately and give all exact values accurately. So that covers what we need to know about the exact values table